The trick about simplifying complex fractions is to not try and do it all at once. In this first example, 3 plus x over 2 plus 1/3, the only thing we should try and simplify right off the bat is the 2 plus 1/3. Since we're going to try and add two fractions together, I need to get a common denominator. So I'm going to multiply this by 3 over 3. The numerator of my fraction will stay the same as 3 plus x. But 2 turns into 6/3, and 6/3 plus 1/3 is 7/3. Then we remember our rule about dividing fractions. Because this big fraction bar, that means division. So this division problem is going to turn into the numerator, and instead of dividing by 7/3, I'm going to multiply by 3/7. And 3 plus x is 3 plus x over 1, so now we're just multiplying fractions. Nothing cancels, so we're left with 3 times 3 plus x in the numerator all over 7. Let's do it again with x plus y over 1/2 minus x. Again, don't try and do the whole thing, just try and simplify the denominator. So my numerator will stay the same as x plus y. But in the denominator, I'm going to need a common denominator. The 2 and the x will give me a common denominator of 2x. In the first fraction, this 1 still needs to be multiplied by x. And in the second fraction, this 1 still needs to be multiplied by 2. So we'll simplify, leaving this numerator the same as x plus y, but the denominator, 1 times x minus 1 times 2, is x minus 2 all over 2x. Again, the big fraction bar means division, so we're going to, instead of dividing by a fraction, we'll multiply by its reciprocal, 2x over x minus 2. When we do that multiplication, nothing is going to cancel, so the whole answer is going to be 2x times x plus y all over x minus 2. For parts C and D, the fractions look a little bit different, but the theory is still the same. Don't try and do it all at once. First, I'm just going to try and simplify that denominator. So I'll still leave my 1 plus 2 over, and the common denominator between 1 and x is going to be x, meaning that 3 would have to be multiplied by x over x, and when I add those two together, we'll have 3x plus 1. Instead of doing this division, we're going to multiply by the reciprocal, so 2 would get multiplied by x over 3x plus 1. Again, we're going to add two fractions together, so we'll need a common denominator of 3x plus 1, which means this 1 needs to be multiplied by 3x plus 1. But the 2x doesn't need to be multiplied by anything. Last thing is to distribute and combine like terms. So 1 times 3x plus 1 is 3x plus 1, and combining 3x and 2x leaves us with 5x plus 1 all over 3x plus 1. So let's do that again. In part D, we're going to take care of the 1/2 plus 1 over x first. So we'll leave 4 and the x in the numerator, and adding together 1/2 plus 1 over x will leave us with a common denominator of 2x, and this first one gets multiplied by x, and the second one gets multiplied by 2. Again, this division is going to be multiplying by the reciprocal, so I'll leave the 4 minus alone, and x is going to get multiplied by 2x over x plus 2. So that's 4 minus 2x squared over x plus 2. Once again, we're going to add two things together, so we need a common denominator. That denominator is going to be x plus 2, meaning the 4 needs to be multiplied by x plus 2. But the minus 2x squared doesn't need to be multiplied by anything. finally, we put it all together as 4x plus 8 minus 2x squared all over x plus 2. If you want, you could rearrange the numerator to put it in descending order with the negative 2x squared first, but that numerator is not going to factor, so this is simplified and we're good.